Hello class, this is a video tutorial on the sum of geometric series. As with the sum of an arithmetic series, calculating large number of terms in a geometric series would be very difficult to add manually. So to calculate the sum of a geometric series for any n number of terms, we use either of these formula. S of n equals a times r to the power of n minus 1 in brackets all over r minus 1, or switching the 1 and the r around. It's the exact same formula, just they will accomplish the same thing. However, the only condition must be that r must be greater than, shouldn't be equal to, must be greater than 1. So if you have any fractional, so 0.1 as your r or anything like that, these will not work. And obviously, I hope we know by now that a is the first term and r is the common ratio. So here are two examples that we're going to be working on. Here we go. So for this, we need the first term, which we can easily see. That's going to be half, or we'll just leave it as 0.5. It's easier to substitute into a formula. The common ratio we need to calculate, we take any term, 21, over 40, and we divide it by the previous term, which is half. I'm just going to put that into a calculator, makes it a lot easier for us. 21 over 40 divided by a half. That's 21 over 20, and I'll just leave it as a decimal, 1.05. So now we have it. Just now using our formula, move it down so you can see it. Substituting it into the formula, we get S of 25 is equal to A, which is 0.5 outside of, R to the power of n, so 1.05 to the power of 25, take away 1, all over 1.05, take away 1. Only point I need to make is I've seen students do 25 take away 1, but it should be this first and then subtract 1. Okay, so that's the only thing they need to be mindful of. Whoops. Into our calculator. 0.5, 1.05 to the power of 25 take away 1 all over 1.05 minus 1. So I'm going to leave this as a fraction if I can. Nope, it won't let me. So the sum of this is 23.8635, etc. And we can just round this off to 2 decimal places. If your calculator lets you, you put it into a fraction, but I can't seem to change it. We'll just leave it as approximately 23.86. But once again, if you can make this into a fraction, you do so. With the same one, but now we want it up until the 50th term, because remember, this symbol means the sum beginning on 1, so n equals 1, all the way to the 50th term. Okay, so using the, I'll just demonstrate using the other formula. You should get the same thing. Here we go. So S of 50 is equal to half to the power of 1 minus r to the power of n, which is 1.05 to the power of 50, all over 1 minus 1.05 So it'd be 0.5, 1 minus 1.05 to the power of 50 all over 1 minus 1.05. This gives us, again, if you can, make this into a fraction if it's possible, 67399, etc. We'll just round this off to 104.67. And there we have it. You could test and just switch these two formula around for either, and you should get the exact same result. Let's try it now for this next example. Let's just give myself some more space. So the terms in a geometric series follow the expression t of tn equals negative 20 times negative 1.1 to the power of n all over 11. So this time we're not given a common ratio or a common or the first term. So we're going to have to calculate all of that first. So remember, we need the first term. We can find that just by substituting 1 into that formula. This one here. Because remember, that is t1, which is the first term. And just showing you what I substituted, negative 20, 1.1 to the power of 1 all over 11. So negative 20. Negative 1.1 it was, yes, negative 1.1, negative 1.1 to the power of 1 all over 11. So the first term is 2. We now need the second term. I'm just going to substitute 2 straight into here. The second term is negative 11 over 5, which negative 2.2. And from this, we can find the common ratio, because in order to find the sum, we need the ratio. So the following term, negative 2.2, over the previous term, which is 2. Negative 2.2 divide 2 is negative 1.1. And now we can find the sum. For this, I'm just going to use the 1 formula, because either will work. And here we go. So now to find S30, we need the first term, 2, times R. R is negative 1.1. Now, here's a little tip. When it comes to substituting negative ratios, it's best to input them in as a bracket like this, because it prevents any errors when it comes to typing it into your calculator. Okay, so same goes with the denominator. So negative 1.1 minus 1. Straight into our calculator. 2 outside of negative 1.1 to the power of 30 minus 1 all over negative 1.1 minus 1. The sum of this, can I make it into a fraction? No, it doesn't let me. So once again, if you can, it seems as if this particular calculator is not powerful enough, but we get negative 15.666097, and I'm sure that it should become a proper fraction, but I'll just round this off to negative 15.67. If you can make it into a fraction, please do so with your calculator. Here we go. Now, one more time, we're looking to find the first 55 terms. So, just now that we have the common ratio and the first term, we can just use our formula here. So, S of 55 is the first term times, just use negative 1.1 to the power of 55 minus 1 all over negative 1.1 minus 1 into our calculator. All over negative 1.1, take away 1. So this is positive 181.008707. Again, let me try and change into a fraction. Oh, it's not letting me. So if your calculator is powerful enough, please do so. It's going to round this off to 2 decimal places. And there we have it. So I hope that gave you an insight into calculating the sum of a geometric series. Using the 2 formula, remember we need to find the first term and the common ratio. Hope to see you in the next video. Best of luck.